to the metallurgist. So I have included this. Okay. Please next, sir. Generally, there is a in heat treatment, annealing, normalizing, hardening, tempering is the basic heat treatment. And case hardening, there is a carburizing, nitriding, flame hardening, induction hardening, and the laser beam hardening. These are the surface heat treatment. In that surface heat treatment, induction hardening is a widely used heat treatment, and today we are focusing on only on induction hardening. Sir, please next. Now, the what is the purpose of heat treatment? There is a mainly it's for internal relieve the internal stresses, improve the machinability, refining the grain size, softening the material, hardening the material, improving the mechanical properties. Uh, so these are the mainly purpose of heat treatment. And what is the requirement in our field? Accordingly, we are selecting the heat treatment and we are doing the heat treatments. Sir, please next. Now we are coming in induction hardening. Mainly induction hardening is the benefit is the hard case and tough core. And main advantage of induction hardening is the low distortion, low risk of scaling, localized heat hardening, where whatever we want to hard, we can hard that portion very easily. Good repeatability in hardening process, easy integration in production line, fully automatic and easy to operate. So these are the main advantages of induction hardening, and so this is a very popular process. For some clips, whatever the basic clips, I am going very fast in that clip. And in the core area, whatever the you are saying that the selection of machine, inductor design, quenching system. So that was the practical thing. We already our wasted our half an hour. So I am taking this fast, and in this core area, I will take my time. And after the completion, we are giving some time for question and answer. In that, you can ask me the actual practical questions. So this is the basic induction hardening process, and this is the principle. This is in this process the magnetic field is generated, and the magnetic field and ED current acting oppositely, and heat is generated. This is the basic principle. So next, this is the general typical induction hardening setup. There is a power supply, AC power supply. Then there is a heat station, that transformer for coils and fixturing. Accordingly, the current is passes. We put our parts in heating coil called as inductor. Heat is generated. This is the typical induction hardening process and setup. This is the process flow. Next, sir. This is general. Hello, sir. In induction hardening section, according to man, machine, material, manufacturing planning, manufacturing control, and product control, if we are working in accordingly, then there is a very good control and good induction hardening system we are following. That these are the graphical presentation. In my next slide, we are going in detail. So next, these are the mainly 4 areas where we want to concentrate and work very minutely. This is the inductor management system, induction hardening equipment, quenching system, and manufacturing process planning. So if we are working in these 4 areas, for that, what is the requirement? whatever the I have studied and to all that I have included in these four sections. If we are working accordingly, then there is no quality concern, and our delivery, our production is mm, we are getting the good result for that. Next, sir. Now in inductor is the main tool, and for that, if we are taking the care for inductor and inductor management, then uh, we are not facing any problems. So for inductor, designing is the most important. According to the customer part drawing, customer requirement, we have to identify induction hardening requirement, and accordingly we have designed the inductor. So to control all that thing, in inductor there is a designing important, procurement of the inductor important. In inductor designing, some designing I have shared here. This is a single coil, and here it is a double coil, and quenching inbuilt that. These are the multi-head induction hardening machines. This is a crankshaft induction hardening, and for that, three power source using at a time, three hardening is going on. This type of inductor, this is the photograph for that. Next, sir. Next, sir. This is a typical inductor, half round coil inductor used for crankshaft hardening. Now, what is the requirement for design inductor design? That is induction hardening locations. You need to know induction hardening locations. What is the diameter? What is the width? What is the hardening cage depth? Hardening pattern width? What is the hardness? Induction hardening machine specification is also important. According to the machine specification, we are balancing the laminations, and accordingly we are designing the inductor. So these factors we need to study, and first before to design the inductor. Next, sir. Now this is the sheet where we can documented what is the whatever the points I am saying, that inductor width, inductor diameter, all that you have to need to make a note, and accordingly you implement. This is in process. So no one parameter is we are missing, and our designing is perfect. Next, sir. These are the drawings and mention that what is the requirements and all that thing. Next, sir. This is the guideline to design engineer how to take inputs from drawings and how to convert it and make a inductor. Next, sir. Hello, next, sir. Next, please. Next. I am here mentioning the total induction inductor management system, whatever the requirement for inductor, all that minor things I am taking, and if we are going accordingly, then it's very good to our sir. So inductor design input, review, sign out. Then next, sir. This is some tips to how the inductor manufacture. Now coming to the most important thing, inductor masters, their manufacturing and their calibration. In some critical parts that like crankshaft, camshaft, we need to check the air gap between the inductor and the part, and to control that we are using the master. For that master, always we have to take the higher specification of our diameter, and this is very inductor gap is a very critical parameter. If we maintain that gap within our specification, whatever DOI we have carried out and whatever the gap we have doing the specification, as an example in crankshaft, generally it is pointed to 1.5. If there is a fillet hardening, then it's up to 2 mm. If we are maintaining very closely these gaps, and that required to check every day or in every shift. So this is accordingly, this is very the inductor alignment is important, inductor gap is important, the checking frequency of inductor alignment with part is important. All that things is coming in this sector. Next, sir. Now the inductor validation. When we are using new inductor, it should be validated. For that, we need to carry out validation trials. First thing is, whatever the process we have developed and whatever the design we have fixed, accordingly our spare inductors we have to manufacture. Whatever the parameters, air gap, width, width of the coil, lamination design, we need to all that inspect, and in different parameters. One is the actual parameter, other is lower side parameter, higher side parameter. We need to take a trial, and after that we are taking the trial. We have to cut the job and check that whatever the cage depth and hardness we are getting as per requirement. Then we have freeze the parameter, list out that parameter, sign off that parameter, and around 50 to 100 numbers batch we have to, as a sample batch, we have to harden on that inductor. Then only we are saying that this inductor is ready for use, and this is a validated inductor. Okay. These are the process how to validate the inductor and all that thing. For that, whatever the format, to how to use that format and all that thing. Next, sir. One more thing is for inductor storage. Inductor storage and control is important. In our inductor, there is a quenchant in the pipeline. It may be damaged to lamination, inductor life. So after completion of production run, we have to clean the inductor, check the inductor, and store it properly. Then there is the requirement of history card. History card is for each and every inductor. We have to maintain the inductor history card. In that inductor history card, first we have to say there, as an example, here the reason of inductor inspection, that is the routine inspection, is a new coil, or is a new inductor, or is a due to any inductor problem during production. All that things we need to write in that inductor history card. Inductor history card is helps us to monitor the life of inductor. In inductor history card, there is weekly or twice a weekly we require to inspect our inductor as per our design requirement, as per our design. After that, whatever the batches we have cutting in that inductor, that MQC report we need to compile with that inductor history card. So inductor history card not only count the how much diameter hardening, but it controls that how much diameter is hardening, inductor inspection, is inductor is okay to use, and is whatever we are using the inductor, the inductor is giving the good result. So inductor history card system is mandatory and is very useful in induction hardening section. Next, sir. That is inductor storage. So that already we have talked. Next, sir. You need to make the work instruction for inductor management. That means how the inductor, whenever the inward inspection is most important. After first you have all drawings for inductor, and accordingly whatever the inductor, new inductors, new coil, you need to develop a system for their inspection, then inductor validation before using that inductor to production. Then when the inductor is in use, then you need to make a inductor history card and track that how much diameter that inductor is hardening, and you are using that inductor, and what is the deadline, how that also you need to decide that around 50,000 or 1 lakh diameter we need to harden on that inductor. After that we have to scrap the inductor. So is all that thing, and the inductor storage system is all that thing is coming in inductor um, management. One more thing, the make of the machine, the capacity of the machine is all we need to think as per the machine capacity, machine make. There is a requirement of inductor design in round vertical machine. In some machine you are using single ton coil, double ton coil. It's according to the our machine specification, machine capacity, machine frequency on that. Other thing, the lamination, the balance of lamination in crankshaft area, that lamination designing and the use of lamination is most important. If the lamination balance is incorrect, then we are facing a lot of problems that you are getting the crack, there is a excessive bend, growth. So like that, all problems we are facing. So inductor designing, using of lamination, using of the paste that called as a fastrol to concentrate heat in the particular area. So all that thing is coming in inductor management system. Another part is the inductor repair control. It's also much most important. A lot of times there is a inductor leakages, increasing the gap, and due to this we are facing quality problems, uh, facing maintenance problems, because due to water leakage, hot water tank is going to empty, and we are facing a lot of problems then. So that is repair control is important. For that repair control, after any repair, you need to validate the inductor again. For repair, you are brazing quality must be very good. For that, you need to use only silver brazing rod. If we are using the copper and brass rod, then also heat loss and other problems we are going to face. So sometimes silver and brass combination of brazing operation that is required. So on that point of view, inductor repair is a most critical area, and for who is going to repair, it should be a good skilled person required. Okay, next. Now we are going in second part, induction hardening equipment, that is induction hardening machine. What is the basic requirement on that? We talk for that. The induction hardening parameters mainly the frequency of the machine, whatever the power we are using, that is the pot reading, what is the time we are using, heating time, voltage, current, quench delay, quench time, quench pressure and quenching flow, quench concentration, rotation speed, and transformer tap ratio, and quench media. These all parameters is the major role in induction hardening operation. Next, next, sir. Huh. And one more thing is in our induction hardening machine, SCADA system is required. And in SCADA system, you are controlling the voltage, current, frequency, power, energy, kWs, quenching flow, quenching temperature, rotation speed, and scanner speed. In right side, there is a machine parameter. So nowadays, SCADA system is going to help a lot. This is the example of SCADA system. In that SCADA system, this is installed in my machine. All parameters we are controlling. Next, sir. This is the main screen. Next, this is the online tracking. Whatever the problems now we are saying that kilowatt current, quench temperature, quench flow, all that online tracking is there. This is the process parameter band. This is we are setting low band and high band, and the actual if there is the process is below low band or above the higher band, then machine is given signal and stop. Next. And these are the automatic report generation. Here, what after the completion of one cycle, one job, you are getting all data, that all the cycle time, cycle number, hardening, energy, everything. If there is any problem, that also coming in that. Next. So in SCADA system, we are controlling voltage, current, frequency, power, energy, kWs, quench flow, quench temperature, rotation speed. So SCADA system is helping a lot. Now machine selection. Coming to the machine selection, for induction hardening machine, mainly whatever the part we are going to harden, you need to uh, check that customer part drawing, identify the induction hardening requirement, and accordingly we have to select the machine. First major parameters we need is the cage depth. So for whatever the cage depth, our requirement accordingly we are going to select the machine. For that, if there is a low cage depth requirement and we need to um, select high frequency machine, it is 100 and 200 kz. If we require 2 to 6, then it is medium frequency machine, it is 2 to 10, around 10 kilohertz. And if there is a above 6 mm requirement, then is a low frequency machine, it is around 3 to 5 kilohertz. Next, sir. So this is the exactly what requirement here. If our requirement is 0.8 to 1.5, and then we need to select 200 to 400 frequency machine. If our requirement is 1.5 to 3 mm, then 10 to 100 kilohertz machine. And if our requirement is above 3 to 10 mm, then it is 10 to 3 kilohertz machine. Next. Here, sir, I am not seeing the total view of my slide. Can you correct it? Otherwise, selection of the cage depth Previous slide, sir. Previous slide. Hmm. If we are selecting the two high frequency machine, then and our requirement is low, then we are giving the more time, more allowing the more heat to conduct to uh, obtain desired case depth, and then is unnecessary time and the cycle time we are using. So selection of machine as per our requirement. If we require high frequency or low case depth, then we require the high frequency machine, and if we require the high case depth, we need to select the low frequency. So this is for that. Next, sir. In machine management area, induction hardening equipment, preventive maintenance and daily check sheet is most important. In that slide, we are mentioning all that thing. So preventive maintenance, how are preventive maintenance checklist, what is the parameter you need to check, all the details is giving in this slide. Next, sir. Next. So this is the example of preventive maintenance sheet. This is the daily check sheet. Whatever the parameter and what is how it check daily, how we are controlling all that thing, that the quenching media, quenching water, all parameters. Whatever the important we think that is the important parameter, daily check sheet is required for that, and daily checking is required. Next, sir. This is regarding the operator training. We need to identify what skill set is required for induction hardening operator, induction hardening inspector, and need to plan the trainings accordingly to the our operator or our inspector. So this is the example for that man matrix sheet. Next, that is the on-job training record. We need to um, maintain all that thing because skilled manpower. Next, sir. Now the section is the quenching. So in quenching, if you know, you have to first study what is the selective diameter you are going to harden, and how the cooling ring design or which cooling is required for that particular part. That need to first study. As an example, in control cooling forging, if we are using deep quenching design quenching media, then we are getting a high heat affected zone. But if you are inbuilt quenching, we are using inbuilt quenching, then the quenching is itself from the inductor, then the heat affected area is minimized, and also we are getting the good result for bend. So that types of study design engineers will do. Then what is the percentage, which quenching media we need to use, what is the cooling graph of that particular material or particular part you need. These all study we have to do, how much the concentration, what is the temperature, uh, whatever the material grade we are using for hardening. Accordingly, we need to select the quenching media. For some low carbon material, around 3.35, the concentration is minimum, and the quenching media also high quenching severity quenchant is required. But for crack sensitive material, we need to increase the concentration, temperature, and also the quenching polymer grade. Next, uh, in quenching, the pressure of the quenchant, concentration, and the temperature, both that all that thing is most important, and it should be controlled properly for getting the good results. And, and for that, our quenching management system need very much effective. Next, uh, this is the example that how to check the quenching concentration and monitoring daily. How that you need to monitor with the help of refractometer your daily quenching concentration. For that, uh, how much, so what is the specification for quenchant concentration, exactly what is that, if there is requirement for adding the water or adding the polymer, you need to take care for that, and you have to record that, and you have to study for also for that. Then the quenching tank cleaning frequency is most important, that not more than 3 months. So these all parameters need to take care carefully. Next, and for that you need to make a system, and you need to daily check on that system. Next, sir. Now we are coming in manufacturing planning. In manufacturing induction hardening section, manufacturing planning is most important. For that, whatever the control plans, PFMEA, that need to use effectively. And generally, what we are seeing that FMEA control plan, our we are not taking much more care for that. But in manufacturing practice, if we are using these tools effectively, then we are getting very good benefits. Next, this is the regarding FMEA. Next, next, next. In FMEA, you have to take care of all the whatever the problems we are coming. You have to take care of all of that parameters. High case depth, low case depth, high hardness, low hardness, growth of the component, bend of the component, internal stresses, all that parameters we have to include in the FMEA. Next, sir. This is the control plan. In control plan, whatever the process parameters you are using, all that process parameters need to track in the control plan. That is, what is the time, potentiometer reading, kilowatt, voltage, all the parameters. You need to take care for that, and accordingly you have to control our process. Next, sir. This is the example of one of the control plan. Next, sir. In induction hardening machine and our manufacturing plan, there is always contingency plan is required. Contingency in the tooling inductor, that is always spare inductor you need to kept ready. Another thing is one is the machine. Your one part you have to establish or validate in 2 or 3 machines. So mm, no problem. You are not easy to make a production schedules and all that thing. From Sanjay Kulkarni, how many parts can be induction hardened from one coil? सर ये जो क्वेश्चन आ रहे हैं अभी भी आंसर दूं या हेलो
सर एंड में
No,
लीजिए
you should answer. You answer after the this. Your lecture.
आफ्टर सेशन मैं सेशन फास्टली लेता हूँ सर और आफ्टर सेशन ज्यादा टाइम देंगे वट एवर द क्वेश्चंस यू आर आस्किंग आई विल गिव यू ऑल द आंसर्स ओके हेलो
Yeah, go ahead.
ओके ओके नेक्स्ट हाँ in induction hardening the induction hardening batch control is the most important. We need to freeze the frequency for cutting frequency for the induction hardening batch. It indicates this is the I am giving the example, but in some cases setup is need start of the production, middle of the production, and end of the production. Some cases only start of the production, but in some cases it may be the frequency 100 numbers, 500 numbers, 100. So it is mutual understanding between the induction heat treater and the customer. But the control of induction hardening batch is most required. Next. This is the I have given the example how to establish the induction hardening batch controls. Next. So if we are started from A, then accordingly this is the one of the examples. If we are saying that in A batch there is a 500 number, then next batch is B, this 500 numbers. The start of the A batch, end of the A batch, then A batch is approved like that. Next. This is the setup approval process. For induction hardening, setup approval is mandatory. Without approval, we not allowed to start the production. So setup approval with systematic way. In setup approval, you need to check and record all the parameters whatever you are using, that may be rotation speed, soft water pressure, quenching water temperature, quenching pressure, like that, all parameters, and then only you have to start the production. Next. This is the setup approval format. This is the one of the example. After you are approving the setup process, then you need to write down all parameters or result in the sheet, and then only you have to start the production. Next. This is the guideline for how to shift-wise manufacturing control you are taking. Yes. Next one. That manufacturing control destructive testing. In destructive testing, how the cut piece guidelines to cut the piece. For camshaft there is a different locations for cutting. Crankshaft there is a different, if there is a gear and axle, so that need to standardize, and accordingly only cutting instruction given to our work. Next. Next. That all this is the system how these all activity together. This is a change management system. Main whatever the changes I have identified here and that mentioned here, that if there is a new induction hardening machine, then internal notification and PPAP is required. Change in power source, new modified inductor, replacement of inductor coil, change in type of quenchant. If you are using, you are changing the quenchant type, shifting equipment from one place to another place, production from inductor not used for 12 months. So these are the guidelines. If this situation happens, then what is the actions requirement? This change point is most important, and control on this change point is required. Next, next. Whatever the non-conformance at the time of induction hardening we are getting, that identified here, that the crack on fillet, that means the crack, you have to scrap, bend, you have to scrap, hardening case depth excess or hardening case depth. So what action needed, that mentioned here. This is the example. You need to establish this type of control in your area. This is the only example. Then you may change the non-conformity, disposition action, or any authority. That is different, but system is required. This is the systematic requirement, that if going accordingly, your manufacturing control, you are taking this all care, then there is no problem in your induction hardening section. Next, sir. This is the production control process audit. Need to define the frequency for process audit, and accordingly you carry on the process audits. These are the guidelines for taking the process audits. Next. Next, sir. These are the format using for process audit. These are the points is in line with CQNN. Next, sir. Next. Next, sir. Mainly in induction hardening, we are facing the problem of residual stresses. So it's very critical. What were the critical parts after induction hardening? If the stresses not removed properly, then the cracking, premature failure of parts, or that problems we are facing. So this is the after induction hardening problems. Next, sir. Defects during induction hardening, that is overheating and burning, quenching cracks, internal residual stresses, dimensional change or growth, soft spots, low hardness, high hardness, bend, runout, microstructure problem. Generally, these are the problems we are facing in induction hardening operations. Next. Then these are the descriptions: overheating and burning of steel, how they occur, what is the reasons for that. So this all that thing I have mentioned here. Next. Cracks, quench cracks, a lot of problems for cracking. For that I have given a fishbone diagram also. Next. This is the reasons, potential reasons for cracking. These are n numbers of reasons. Due to this, we are getting the cracks. And this fishbone diagram is very helpful to induction hardening person. Next. Generally, the again internal residual stresses. This is the main problem which we are facing, and we are not getting the exact problem solution for that particular reason. We need to take a lot of data and study, and then only we are getting the in your question and answer I will give the much more information about internal residual stresses. This is mainly after induction hardening, whatever the operation, grinding and turning operation, this problem is we are giving trouble to us. It may be in the camshaft, after camshaft grinding or crankshaft grinding or any other critical part. Next. This is the dimension changes. This is the growth. This is generally for camshaft, crankshaft, and axle. This is the giving the problem. Next. Spot. This is a we are generally not looking given not much more intention to that soft spot. These spots are lower hardness can result due to manpower, mainly agitation of the quenchant, and due to the lubricants and other impurities on the surface of the job. Proper cleaning of the job is required before hardening. Generally, we are not clean the jobs, and due to this spot is coming. Then if we are using only water, then also that spot is coming. These are the reasons for that. Next. This is the low hardness. Next. Okay. Now I'm ready to the question and answer session. That is more practical, and so I am taking this. Okay. So one by one we will you ask the questions accordingly. We go for question and answer session. Hello, sir.
Thank you very much, Avinash ji. Your presentation was nice, and we could see that a lot of efforts have been taken while doing this presentation, though it was quite long. But of course, that topic of induction hardening is not so small that we'll be able to cover it within say 45 minutes to 1 hour. So thanks for your efforts, sir. And there are a few questions. One is, what are those defects associated with induction hardenings that can get skipped in further inspection, and chances of those getting exposed at end customer in the service life of the part? So you can answer this. If you want, I can repeat the question.
Uh,
Yeah. So what are the defects which are associated with induction hardening
mm,
and which can get skipped in further inspection,
uh,
and they may get exposed at the end of the customers in the service life of part?
yeah,
So
okay.
what could be the,
Sir,
yeah,
can I answer? Okay.
yeah, please
For
answer.
that, the micro hardening cracks. These are
Mm-hmm.
the defect which were not identified in our end, but it may be exposed in field or when the part is going to customer and at the customer end.
Yeah.
This is due to after induction hardening. If the hardening is not proper, if the quenching severity is much more high, material is high hardenability material, then there is a micro crack that cannot be identified in our MPI or in our inspection, but this micro crack is open in field or in working time. For that, Toyota has a very good system to identify this crack, what they are doing? They are doing the SCL test. Means after induction hardening, they put the component half hour in SCL 30% concentration solution and check for MPI. If there is a micro crack that was open and that was revealed in MPI. Another thing, after tempering, same carried on, and that also, if there is a part, there is no crack, then we are not getting the cracks in MPI. But if there is a micro crack that was open and that identified, this is the one of the system or solution or test to identify that the micro hardening cracks. So that micro hardening cracks that is not identified in our area, but identified in another thing is microstructure. It may be sometime that we are not identified microstructure abnormalities in our area, but after the part is failure or in customer premises, we will get to know that there is a problem. That so microstructure abnormality is the one of the, yeah. Then another is if you are doing the MPI after induction hardening tempering, then residual magnetism is another problem that's not identified sometime in our area, but it may be identified in a customer area. These are the some examples of the problems which are not identified in our area, but it may be identified in customer area. Next question, sir.
Yeah. So thank you very much. A nice way of doing it with Toyota, right? The other question is how many parts?
Okay.
Sorry.
Okay.
What
Nitin?
you have told? The second one?
Hello.
Second one was microstructure. He
Microstructure
said
abnormality.
that microstructure cannot be. First thing the Toyota does, yeah, for micro cracks, Toyota does it for half an hour in 30, and those parts are dipped into it, and there is one part, the number one. Second, he talked about is a microstructure which cannot be identified in the process and can get identified at supplier end. And the third one, he said that this magnetism. So after MPI, if you don't demagnetize, that magnetism can go ahead and supplier can identify that. Second question is how many parts can be induction hardened from one coil? So what is the life of a coil he is talking about it?
Generally, it is different for different coil design. As an example, I will say that if the fillet hardened crankshaft half round coil, it may be up to 1 lakh. If this is a non-fillet, it may be 1,50,000. If there is a round coil, it is around 2 lakhs. So that is the study, and up to that, we are not getting any problem. But it is how the lamination design, handling, how the handling of the inductor is depend on that. But this is the generic.
Another question. Yeah, that's yeah. So 1 lakh is the life normally. Yeah, for crankshafts. Yeah. So how to differentiate between crack generated due to induction hardening parameters or due to inherent steel defects?
That generally for induction hardening, whatever the crack generated, that is the nature is zigzag line. Okay, and due to material, it is inclusions, crack, and that is not related to heating.
Yeah.
Also,
Is reworking? Yeah. Yeah. Go ahead. Go ahead. Go ahead.
also in grinding there is a grinding crack. There is a bunch of indications in identified the grinding and is one line. But in induction hardening there is the zigzag type of nature, and it is not a sequential. It how the heat is produced and accordingly it reverse.
Another question is reworking of already induction parts safe? Can you redo the induction hardening, and whether it is accepted by the industry?
Uh, there is a procedure for rework of induction hardening parts. In some industry, they are straightway say that rehardening is not allowed, but in some industry they are allowed for rehardening. The process is that after induction hardening completed, you need to normalize this part in same cycle, increasing 1 second approximately. Means if you are using 10 seconds in induction hardening as a time, then you need to use 11 seconds, 10% more time, and normalizing the part, air cool that part, not cooling, and after that again you go for rehardening. This is the procedure. Direct hardening and then again rehardening
Okay.
is not allowed. First you need to do the normalizing process, and then you again use normalizing with the help of same coil and particular that area, and then only you go for hardening. But first hardening and then again rehardening, that is not allowed.
Okay. Is there any how to control induction hardening runout, and any
So
procedure for compensating the observed runout in tempering process? How to control runout during induction hardening? That's the question.
this is a very big area, sir. Whatever I will shortly tell you. In runout, you first you need to work on your machine
Yeah.
alignment, the clamping center, dead center and tailstock center. There is requirement of spring actions required. When the part is induction hardening, that time the part is expand. That expansion need to take care by the tailstock centers and dead center. If that was not happen, then you are getting bent. Another thing is the balancer, use of the balancer. When your inductor is on the job, the weight should be minimum. For that, you need to take the support of balancer. That arrangement newly provided by the machine. Then another is the care at the time of taking going for setting, that the tailstock pressure, that is also important. Another thing, rotation and the coil gap. Excessive, if there is a excessivity, then also you are getting the excess runout. So these are the n number of reasons you need to work out on your machine and things. One another thing is, if there is a sequence problem, then also you are getting the bend. So you need to work on the hardening sequence, that is also required. Hanging of the material is another part. If the hanging at the time of clamping, hanging is more, then also you are getting the water. And the remedy, how to improve this, also there is a 2 3 techniques I will tell you. One is press tempering. So whatever the axle, crankshaft, camshaft, if there is a bend, Then at the time of tempering, you have to use the fixture and go for press tempering operation. Another thing is using the bolt, male female bolt, that generally used in crankshaft to remove the crankshaft bend. Then so in some cases that is not allowed in process, but rehardening a particular area and compensate the bend. It means in crankshaft, if there is a bend, you need to only rehard the center two pins. Then also the bend is you are getting the you remove the bend. So and also in tempering operation we observe the bend. So loading system is important at tempering operation. Generally required horizontal loading with high bend point upside. These are the standard process. So these are the so in tempering operation also you are getting the bend. Generally in tempering operation you need to minimize the bend. This is a good operation. Whatever the bend you are getting in hardening, you can remove these bend in tempering operation. Any question? Hello?
Tempering on induction machine, whether it is acceptable.
Yeah. Tempering on induction machine is nowadays acceptable. A lot of customer going for that, but for that you need to study the thing that after tempering operation you need to check the residual stresses values. If that is in minus, then yes, your tempering operation is okay. So machine tempering is no problem, and nowadays lot of customer is using that machine tempering operation. Only thing is you take care for internal stresses.
So, sir, there is another question. Season crack. How that season crack occurs, and what is the phenomena? Season
Season
crack.
season cracks is due to delayed tempering operation. That is high hardenability material. If you are not doing tempering within 3-4 hours, then that type of phenomena we are observing. So after induction hardening, immediately tempering is required. These are the only solution.
Sorry, sir.
Can
I need to
interrupt
ask
it.
further on this.
Yes.
Can I interrupt? Sorry.
Yes.
So regarding season crack,
Yeah, go
you
ahead,
said
go ahead.
about within 3 to 4 hours. So actually, is there any standard guideline should we follow, or just we are saying based on experience that it will be in within 3 or 4 hours? Do we have any standard guideline?
No, sir. This is the as per the instruction and is mentioned in CQI 9. If you are asking, then this is the mention in CQI 9. Okay, but that is
As
on
per
experience
CQI
only.
9, what is the guideline? Sorry.
It is 3 hours, sir.
Within 3 hours.
Within 3 hours.
Okay.
Okay.
Thank you so much, sir.
But
Yeah.
if the material is around 0.4% carbon, then
Mhm.
up to 48 hours there is no any problem. What we have observed. Okay, but
Mhm.
some material which is hardened tempered, previous heat treatment is there, and carbide formation material is there. There, this is the possibility of delayed cracking, season cracking.
Okay. And last thing I just want to know, because you said you are saying inductor and coil. So what is the difference? Sorry, I'm not metallurgist guy, so I just want to know.
Okay, sir. Inductor means is the total assembly of
the machine
whatever,
assembly, we are saying.
not machine assembly, whatever the tooling we are using for heat the component, okay, that component
Okay.
total assembly is called as a inductor, and heating element. So inductor, generally whatever the round inductor, round coil. So you are saying that round coil is the only coil, and if you are saying inductor, then it may be total assembly, the round coil, the quenching coil, everything. That is called as the inductor,
Thank you,
total
sir.
assembly.
Yeah.
Thank
So
you.
this is in
Yeah. So
crankshaft.
there is another question.
Generally,
Can
this
interrupted?
inductor,
Yeah.
hello, inductor word is used in crankshaft induction hardening. So crankshaft, there is a half round coil, and supporting that coil, there is a requirement of plates and all the structure. So it called as a inductor, and only the heating element is a coil. In round, there is a only coil, and the if the cooling arrangement is coming with that coil, then it is an inductor, like that.
Yeah, I think there are many questions, so we'll take only three now. It's high time now. So rest of the questions we will you can direct presentation. Okay, so that's yeah. So how to monitor and what are all parameters to consider for inductor life? I think he has spoken about inductor life as around 1 lakh parts numbers. So monitor and parameters, I think he spoke about it in the, he has given that table how to monitor the things. So that you can refer. About
To
another question, please let us know some,
sir,
yeah,
to
good.
monitor the inductor life and improve the inductor life, we need to install the inductor management system, including that the frequency of inductor inspection that need to establish. Every ship you need to check the inductor gap. Weekly you thoroughly check the inductor. So if we are effectively doing all that thing, then definitely we are getting the good inductor life. Also, the soft water pressure, whatever inductor cooling system is there, that is one of the reasons premature failure of inductor is inductor cooling system is not proper. So that soft water temperature and the pressure is important. And there is a profile required. If inductor flow or pressure is low, then machine should not to start, or machine should not start the hardening. So inductor cooling system, effective inductor cooling system is required.
Yeah, there is another question. Do we have flexible machines where we can select required frequency from high to low?
Yes, sir. This called as a dual frequency machines. There is a tap selection. If you required 10 frequency, you can use 10 frequency. If you require 60 or 50, whatever the select, you can use that machine also. So nowadays that dual frequency machine is available.
Yeah. The last questions we'll take for today's day. I mean, per AMS 2750, calibration of controller and recorder is required. How to calibrate if we use SCADA system, or how to calibrate SCADA system itself? So this is the last question for tonight. Yeah.
Okay,
Rest questions can be answered directly by the speaker. You can talk to him later on.
okay, sir. Okay.
Yeah.
Uh, in
Yeah.
SCADA
So
system,
as per, yeah.
in SCADA system, whatever the energy meters, flow meters we are using, that data only coming in the SCADA system. So energy meter calibration agency is available, flow meter and all that meters calibration agency is available. From that meters we are taking the data only, so that if we are calibrating that, then it's the only requirement, sir.
Yeah,
Okay.
sorry, can I interpret here? Can I ask here why I am specifically asking this? Because
Yeah, go ahead.
as per AMS 27, yeah, as per AMS 2750, there is a requirement to calibrate the recorder, right? And when we using a SCADA system, that is our recording means or
Software.
system. Software, yes.
Software.
So generally, like when we go for the audits, like they are asking, like, do we have the calibration report for the recorder or not? And also, like, they are asking for a system accuracy test set calibration as well. So how to do that for
That
SCADA
is
system?
that is possible for steel cage furnace and other heat treatment furnace SCADA system. But in induction hardening, whatever the meters, that calibration we are doing, and up to SCADA system, SCADA person is not giving any calibration certificate, sir.
Okay, so for SCADA, calibration is not possible.
Not
That means, right?
not and that agency is a private agency. They are saying that whatever we are taking only the data from flow meter, data from energy meter, and that is the only presentation like that.
Okay, okay, got it. Thank you.
Oh, oh.
So thank you very much. Thank you very much, all the participants. In spite of a delay in starting and delay in closing, there are still a lot of questions which are unanswered. Unfortunately, due to paucity of time, we are not able to take it up further. And we'll take it up. You may take it up directly with Kare sir. So thank you very much, Kare sir, for your nice presentation, and which was very informative. And with the knowledge you have, I think we have some less time in disseminating knowledge. So we can discuss this in separately with you with ASM India chapter, how to go ahead with your a specific lecture on specific topic, and we will take it up so that you will be able to give justice to in totality to the induction hardening per se. So we'll take it up separately with you, how to take it up forward with maybe a 3 hours lecture or 4 hours lecture, and then maybe a lot of things will get clear. So participants, we will do that in some time. Till then, for tonight, we sign off from Mumbai. So thank you very much again, Avinash Kaliji, and the participants here. Thank you very much. Good night.
Thank you very much, sir. Sorry, I am taking much more fastly because the time limit is there. Okay,
Yeah.
next time whatever you are saying, accordingly I go.
नाही आपण एक स्पेसिफिक तुमचं लेक्चर घेऊया maybe for 3-4 hours, so that we will be able to, you'll be able to give justice to the topic.
Yes,
Okay.
sir, yes, sir.
I could find out that you have a lot of knowledge, and you will not be able to give justice to that.
Yes,
So
sir.
we will
Well,
definitely take it up, and there is a lot of requirement of this knowledge in the field. So we will definitely take it up. Thank you very much, and good night, sir.
thank you. Good night, sir.
Thank you. Good
Thank
night.
you to
Good
all.
night. Thank you all the participants. Thank you.
Thank you.